A gravel turnoff on a two-lane highway in the interior of the Ngava Peninsula, where nothing moves except wind across low tundra scrub and gray granite shelf. No sign, no guardrail, no monument to mark the spot. The land looks empty, uniform, and entirely unremarkable to anyone driving past at 80 kilometers an hour. Then you look at a satellite altimetry map and realize the entire continent drops into a structural depression here, a gravitational deficit so large that a pendulum hangs fractionally off vertical because a trillion tons of ice pressed the Earth's mantle out from under Quebec 10,000 years ago, and the crust is still rising to meet it. What is remarkable is not that the continent is still recovering from the Ice Age, but that an anomaly covering 3 million square kilometers went completely unmeasured until satellite geodesy picked it up in the late 20th century. Why does a vast stretch of North America weigh less than it ought to? And what else is sitting unnoticed beneath the surface of these 13 provinces and territories? Mid-list, near item 22, lies a magnetic point sprinting across the high Arctic toward Eurasia. Near the end, at item 3, an impact structure in northern Quebec forms a ring of water so perfectly circular it was used as an orbital navigation landmark before anyone proved a meteor had struck the Canadian shield. We begin the countdown at 43 on the Atlantic coast, in the province of Newfoundland and Labrador. Number 43, the peninsula where the Earth's mantle sits exposed to the open sky. On the western coast of Newfoundland, inside Gros Morne National Park, lies the Tablelands, a barren plateau of dark yellow and orange rock where almost nothing grows. Local residents long assumed the soil was simply poisoned by salt or timber harvesting. In the 1960s, geologists with the Geological Survey of Canada confirmed something far stranger. The Tablelands are a slab of the Earth's mantle, forced up from 20 kilometers beneath the ocean floor during a continental collision 490 million years ago. Heavy iron and nickel in the peridotite rock make the ground toxic to most plant life, leaving a section of the Earth's interior exposed directly to rain and wind. Number 42, the island that moves 30 meters a year and eats ships. Sitting 300 kilometers southeast of Halifax, Nova Scotia, Sable Island is a narrow crescent of sand 42 kilometers long and barely 1 kilometer wide. It sits on the edge of the continental shelf, surrounded by shallow sandbars and violent Atlantic currents. Since the late 16th century, more than 350 ships have run aground on its shifting shoals, earning it the title of the Graveyard of the Atlantic. Because ocean currents constantly erode sand from the western end and deposit it on the east, the entire island is physically migrating eastward, carrying a population of over 500 wild horses whose origins trace back to livestock left by 18th century expedition attempts. Number 41. The tidal surge that reverses a river twice every day. In St. John, New Brunswick, the St. John River meets the Bay of Fundy through a narrow rock gorge. The Bay of Fundy experiences the highest tidal range on the planet, rising up to 16 meters twice in 24 hours. When the tide comes in, Atlantic water overpowers the river's downstream flow, forcing water to run backwards through the gorge and creating violent rapids that flow upstream for hours before the tide recedes and the river resets. Number 40. The provincial border defined by a line no surveyor had ever walked. When Prince Edward Island joined Confederation in 1873, its land ownership was a mess of 18th century British grants. Less known is the land anomaly at Confederation Bridge, where the boundary between Prince Edward Island and New Brunswick sits in the middle of Abegweit Passage. When survey teams mapped the strait for bridge construction in the late 1980s, they discovered 19th century shorelines had eroded by over 90 meters in certain sectors, meaning the physical midpoint between the two provinces had shifted significantly since original charts were drawn in 1845. Number 39. The lake formed by an ancient meteorite impact so vast it created its own internal weather system. Located in central Quebec, the Manicouagan Reservoir is a ring-shaped lake 70 kilometers in diameter, easily visible from space as a giant blue eye in the Canadian Shield. Cartographers long mapped it as two separate crescent-shaped lakes. In 1958, geologists with the Geological Survey of Canada analyzed core samples and identified shocked quartz, proving both crescents formed the outer ring of a single impact crater dating back 214 million years. When Hydro-Quebec dammed the Manicouagan River in 1968 for the Daniel Johnson Dam, rising waters flooded the central uplift, creating René Levasseur Island, an island larger than the surrounding lake water, sitting inside a crater caused by an asteroid 5 kilometers wide. Number 38. The ghost towns resting 40 meters beneath the St. Lawrence Seaway. On July 1, 1958, a controlled detonation broke a cofferdam near Cornwall, Ontario, flooding over 20,000 hectares of land to complete the St. Lawrence Seaway project. 10 communities, known as the Lost Villages, disappeared under the rising river in less than 24 hours. Roughly 6,500 people were relocated, while houses, schools, and cemeteries were submerged. Today, during low water conditions, scuba divers and aerial survey drones can still trace intact asphalt roadways, sidewalk grids, and concrete building foundations standing silent on the riverbed. Number 37. The 2-billion-year-old scar that supplies a major portion of the world's nickel. In 1883, workers blasting bedrock for the Canadian Pacific Railway near Sudbury, Ontario, exposed a dense vein of copper and nickel ore. Early prospectors assumed the mineral wealth came from a standard volcanic belt. Decades later, mineralogists proved that the 60-kilometer-long Sudbury Basin was created by a bolide impact 1.85 billion years ago. The impact shattered the Earth's crust, melting surrounding rock and allowing mineral-rich magma from deep below to rise along the crater's rim, creating one of the richest mining districts on the continent. Number 36. The sand spit that creeps southward into Lake Erie and traps ships in shifting shoals. Point Pelee, extending 15 kilometers into Lake Erie from Essex County, Ontario, is the southernmost tip of mainland Canada. Built entirely of sand and gravel deposited by glacial meltwater 12,000 years ago, the spit is constantly reshaped by opposing lake currents. Erosion sweeps sand from the western shore and deposits it on the eastern edge, causing the tip to shift hundreds of meters over decades, frequently stranding commercial vessels on uncharted sandbars that did not exist on nautical charts drawn 10 years prior. Number 35. The northern lake where cartographers gave up counting islands. Lake of the Woods straddles the borders of Ontario, Manitoba, and Minnesota, covering over 4,000 square kilometers. Official hydrographic surveys by Natural Resources Canada list 14,552 islands, but local survey teams regularly dispute the exact number. Because post-glacial rebound is lifting the northern shoreline faster than the southern shore, water levels fluctuate unevenly across the basin, causing low-lying reefs to constantly merge into single islands or split into multiple landmasses over human timescales. Number 34. The city built inside a giant glacial spillway. Winnipeg, Manitoba, sits at the confluence of the Red and Assiniboine rivers, occupying a flat basin that was once the bed of Lake Agassiz, a colossal glacial lake larger than all the modern Great Lakes combined. When the ice dam holding Lake Agassiz collapsed 8,000 years ago, it drained millions of cubic meters of water in a matter of months, leaving behind a lacustrine plain so flat that spring floodwaters have nowhere to flow, regularly submerging thousands of square kilometers of farmland. Number 33. The international boundary marked on paper in 1818 that survey crews spent 4 years physically searching for in the prairie grass. Under the Convention of 1818, British and American diplomats agreed that the border west of Lake of the Woods would follow the 49th parallel to the Rocky Mountains. Neither negotiator had ever set foot on the northern Great Plains. When the International Boundary Commission sent field survey parties out between 1872 and 1874 to mark the line, astronomical observations revealed early British Admiralty maps had mislocated Lake of the Woods by over 40 kilometers. To maintain legal continuity, surveyors had to construct a north-south cut line through dense swamp to connect the northwest angle to the 49th parallel, creating an isolated Pelee exclave accessible by land only through Manitoba. Number 32. The sand dunes sitting deep in the boreal forest that shouldn't exist this far north. On the southern shore of Lake Athabasca in northern Saskatchewan lie the Athabasca Sand Dunes, stretching for 100 kilometers along the coastline. Rising up to 30 meters high, they form the most northerly active sand dune field on Earth. Early fur traders assumed sands were blown in from dry desert basins to the south. In the late 20th century, geologists with the Saskatchewan Geological Survey used heavy mineral analysis and luminescence dating to prove the dunes were derived entirely from local sandstone bedrock, ground down by glacial meltwater 10,000 years ago and pushed onshore by prevailing winds. Number 31. The mineral field found by following garnet trails across thousands of kilometers of ice-scoured shield. For over a century, mining syndicates operated on a strict consensus. The Canadian Shield was too young and tectonically altered to host diamond-bearing kimberlite pipes. In the late 1970s, geologists Chuck Fipke and Stuart Blusen challenged that assumption. Using heavy mineral soil sampling, they collected till samples across the Northwest Territories, painstakingly tracing microscopic pyrope garnets and chrome diopside grains upstream against ancient ice flows. In 1991, near Lac de Gras, their drill rig punched through 50 meters of lake ice and till into a kimberlite pipe, opening the Ikati mine and proving Canada held one of the richest diamond districts in the world. Number 30. The subterranean mountain range buried beneath 2 kilometers of oil-soaked sand. The Athabasca oil sands in northern Alberta hold over 160 billion barrels of recoverable bitumen, coating an area of 140,000 square kilometers. For 2 centuries after fur trader Peter Pond recorded First Nations using surface tar to seal canoes in 1778, geologists struggled to explain why such a massive concentration of heavy hydrocarbons sat near the surface. In the late 1970s, deep seismic reflection profiles conducted by Energy, Mines and Resources Canada revealed bitumen was not formed in place, but had migrated hundreds of kilometers eastward from the Rocky Mountains along underground carbonate faults, becoming trapped where ancient Devonian salt beds had dissolved and collapsed. Number 29. The lake in the Rocky Mountains that disappears through its own floor every autumn. Medicine Lake, located in Jasper National Park, Alberta, fills with glacial meltwater every spring, reaching a length of 7 kilometers. By late summer, without any visible surface outlet, the lake level drops dramatically, turning into a mudflat by autumn. Early European visitors assumed water evaporated. In the 1970s, hydrogeologists introduced fluorescent tracer dyes into the lake bed and tracked water using spectropluorometers. They discovered Medicine Lake sits over one of the largest inaccessible cave systems in North America, with water sinking through sinkholes in the lake bottom and traveling over 16 kilometers underground through limestone conduits before emerging downstream at Moline Canyon. Number 28. The submerged valleys flooded under an international treaty that drowned 9 communities. Under the 1961 Columbia River Treaty, Canada agreed to build 3 major dams in British Columbia to control flooding and generate hydroelectric power for the northwestern United States. The completion of the Keenly Side Dam in 1968 raised water levels of the Arrow Lakes by 14 meters, inundating over 15,000 hectares of fertile valley floor. 9 communities, including Arrowhead and Renata, were completely submerged. Today, side-scan sonar surveys conducted by university research teams regularly map flooded orchards, concrete bridge abutments, and railway beds resting intact beneath 40 meters of water. Number 27. The Arctic coastline that is crumbling into the ocean at a rate of several meters every summer. Along the Beaufort Sea coast in the Northwest Territories, near the hamlet of Tuktoyaktuk, coastal bluffs made of permafrost and ground ice are exposed to longer, ice-free, open water seasons. When storm surges hit the shore, frozen ground thaws instantly, causing massive retrogressive thaw slumps. Entire shorelines are receding by up to 10 meters annually, swallowing historical whaling structures, archaeological sites, and municipal roads, forcing the community of Tuktoyaktuk to plan a gradual relocation inland. Number 26. The high-altitude ice patches that are melting and revealing ancient hunting technology untouched for millennia. In the southern Yukon, high alpine snow patches that remained frozen for over 9,000 years are rapidly shrinking due to rising regional temperatures. As ice thaws, it releases organic artifacts preserved in perfect condition. Wooden dart shafts, sinew lashings, and stone projectile points crafted by First Nations hunters thousands of years ago. Through the Yukon Ice Patch Research Project, scientists from the Yukon government and local First Nations co-manage the recovery of these fragile items, which decay within days once exposed to air. Number 25. The northern town built on ice mounds that collapse when the ground warms. Around Tuktoyaktuk and across the Mackenzie Delta, hundreds of conical hills called pingos dot the flat tundra landscape. Rising up to 50 meters high, pingos are formed when pressurized groundwater freezes underneath the tundra surface, pushing up a core of solid ice covered by soil. As permafrost degrades, internal ice cores melt, causing the centers of these landforms to collapse into crater-like lakes, destabilizing northern foundations, winter road networks, and airstrip infrastructure. Number 24. The vast mineral deposit trapped beneath hundreds of kilometers of peat bog with no road access. Located in the James Bay lowlands of northern Ontario, the Ring of Fire is a major mineral reserve holding massive deposits of high-grade chromite, nickel, copper, and platinum. Discovered in 2007 by regional aeromagnetic surveys, the deposit sits beneath a massive wetland complex, one of the largest peatland carbon sinks on Earth. Because the region lacks all-season road infrastructure, industrial development remains tied up in complex environmental assessments and consultations with local First Nations, balancing multi-billion-dollar mineral estimates against ecological risks. Number 23. The coast where the seafloor is rising out of the water at a centimeter a year. Along the shores of Hudson Bay, post-glacial rebound is lifting the Earth's crust faster than almost anywhere else on the planet. Freed from the weight of the Laurentide ice sheet, the land rises roughly 10 millimeters per year. Historical harbor moorings built by the Hudson's Bay Company in the 18th century now sit hundreds of meters inland, high above current sea levels, turning former coastal mudflats into dry willow thickets and forcing marine charts to be continuously updated by the Canadian Hydrographic Service. Number 22. The magnetic point that keeps sprinting across the Arctic toward Eurasia. The Earth's magnetic North Pole, first localized by explorer James Clark Ross on the Boothia Peninsula in Nunavut in 1831, remained relatively stable within Canadian territory for over a century. Since the late 1990s, satellite magnetometry tracked by Natural Resources Canada revealed the pole's drift speed accelerated from 15 kilometers per year to over 55 kilometers per year, crossing the international date line out of the Canadian Arctic towards Siberia, and requiring global navigation systems to update magnetic variation algorithms far more frequently. Number 21. The river in the Northwest Territories that flows through hundreds of meters of karst caves before plunging into limestone canyons. In Nahanni National Park Reserve, the South Nahanni River flows through the Mackenzie Mountains, carving gorges over 1,000 meters deep. The surrounding limestone plateau is perforated by Sinkhole Flat and the Grotto Creek cave system, where underground rivers carve labyrinthine passages that remain largely unmapped. Dene oral tradition long spoke of hidden valleys and rivers that vanished into stone, a reality geologists confirmed when dye tracing studies by the Geological Survey of Canada revealed subterranean connections stretching across dozens of kilometers of rugged alpine terrain. Number 20. The vast interior plateau of Labrador that sat as a blank spot on official hydrographic maps well into the 20th century. Covering tens of thousands of square kilometers, the Labrador Plateau is a complex mosaic of interconnected lakes, eskers, and bedrock ridges. When aerial photography surveys conducted by the Royal Canadian Air Force began systematic mapping after the Second World War, cartographers discovered entire river networks flowed in directions contrary to 19th century hand-drawn charts, with water bodies regularly changing discharge outlets depending on seasonal meltwater levels. Number 19. The mountain valley where thermal springs create a microclimate of lush vegetation surrounded by subarctic tundra. In the far reaches of the Yukon, Coal River Springs features massive tufa terraces built up over thousands of years by mineral-rich groundwater rising from deep crustal faults. Warm, calcium-saturated water maintains a constant temperature year-round, allowing plant species typical of temperate forest zones to thrive hundreds of kilometers north of their normal range, surrounded by permafrost and stunted black spruce. Number 18. The alpine ice patches releasing frozen hunting weapons that predate the Egyptian pyramids. In the Selwyn and Ogilvie Mountains of the Yukon, ice patch archaeologists working alongside the Champagne and Aishihik First Nations have recovered over 200 organic artifacts. Radiocarbon dating on preserved wooden dart shafts and leather bindings indicates hunters utilized these exact ice patches as cold storage hunting grounds for caribou over 9,300 years, creating an unbroken physical record of human technology frozen in time. Number 17. The ancient impact ring in Quebec, so perfectly circular that astronauts used it as a landmark from Earth orbit. Lake Pingualuit, located on the Ungava Peninsula in northern Quebec, occupies a meteor crater 3.4 kilometers in diameter. Formed roughly 1.4 million years ago, the lake is fed exclusively by precipitation, containing some of the purest fresh water on Earth, with water clarity extending to over 35 meters depth. Because it lacks river inlets or outlets, sediment layers at the bottom of Lake Pingualuit remain undisturbed, preserving a continuous climate record spanning multiple glacial cycles. Number 16. The massive low-gravity anomaly sitting directly beneath Hudson Bay. Satellite gravity measurements gathered by the GRACE mission confirmed Hudson Bay exhibits a significantly lower gravitational pull than the surrounding planetary surface. Geophysicists determined two distinct mechanisms cause this deficit: incomplete post-glacial rebound of the crust following the melting of the Laurentide ice sheet, and deep mantle convection currents pulling tectonic material downward. The Earth's surface here is literally depressed by hundreds of meters, recovering at a rate scientists can measure year by year. Number 15. The island in the high Arctic mapped from the air long before any surveyor set foot on its interior. Axel Heiberg Island, located in Nunavut at 79 degrees north, features vast salt diapirs, domes of ancient rock salt pushing upward through kilometers of sedimentary rock, creating arid, desert-like structures in the middle of Arctic glaciers. Aerial photographic surveys in the 1940s first revealed these giant white hills, which were initially mistaken for snowdrifts until ground expeditions by the Arctic Institute of North America confirmed their mineral composition in the 1950s. Number 14. The giant pingos of the Arctic coast that act as natural ice houses preserved by permafrost. Ibuk Pingo near Tuktoyaktuk rises 49 meters above the surrounding coastal plain and grows a few millimeters each year as groundwater freezes beneath its core. For centuries, Inuvialuit communities utilized natural ice cellars dug into frozen soil of regional pingos and permafrost layers to store harvested meat at stable, below-freezing temperatures throughout summer months. Number 13. The vast inland delta where three major river systems meet to form a continuously shifting wetland. The Peace Athabasca Delta in northern Alberta covers nearly 6,000 square kilometers, forming one of the largest freshwater inland deltas in the world. Because the delta is extremely flat, small changes in water levels cause dramatic shifts in channel flow, with rivers occasionally reversing direction during spring ice jams and flooding thousands of square kilometers of sedge meadows. Number 12. The deep ocean fjord in Saguenay, Quebec, where cold Arctic water sits trapped beneath a layer of fresh river water. The Saguenay Fjord occupies a deep glacial trough carved into the Canadian Shield, reaching depths of over 270 meters. A shallow sill at the mouth of the fjord prevents deep, cold salt water from escaping into the St. Lawrence estuary, creating a unique marine ecosystem where deep-sea Arctic species live just below a thin surface layer of warm, fresh water. Number 11. The tidal bore that surges up the Shubenacadie River in Nova Scotia twice a day. As the tide rushes into the Minas Basin, it forces a wall of water up to 2 meters high to travel upstream against the river's natural current. Incoming Atlantic water transforms calm mudflats into roaring whitewater rapids within minutes, altering the riverbed's sandbars on every tidal cycle. Number 10. The vast impact crater hidden beneath the city of Sudbury that shaped the industrial geography of Ontario. The Sudbury structure spans 60 kilometers long and 30 kilometers wide, forming an elliptical ring of mineralized rock created by a bolide impact nearly 2 billion years ago. Impact breccia and sublayer rocks host some of the largest concentrations of nickel, copper, and platinum group elements on Earth, driving over a century of heavy mining and metallurgical refining that fundamentally altered the regional landscape. Number 9. The moving sandspit of Point Pelee that extends into Lake Erie as the southernmost land in mainland Canada. Formed by glacial till and coastal erosion, the spit's geographic tip shifts dynamically in response to storm surges and wave action, constantly reshaping the boundary line between land and water. Number 8. The subarctic forest of the Ring of Fire in northern Ontario, where massive chromite beds sit buried under peat bogs. Aeromagnetic surveys revealed these mineral deposits lie beneath hundreds of square kilometers of saturated muskeg, presenting unprecedented logistical challenges for infrastructure development and environmental protection. Number 7. The vast bitumen deposits of Athabasca, where ancient oil migrated over hundreds of kilometers from the Rocky Mountains, coating over 140,000 square kilometers of underlying Devonian limestone, the sands represent one of the largest hydrocarbon accumulations on the planet, requiring complex industrial techniques to separate heavy bitumen from sand grains. Number 6. The vast salt formations of Avery-style domes beneath the Gulf of St. Lawrence. Subsea seismic reflection profiling has mapped massive salt structures beneath the seafloor, where ancient evaporite layers have buckled upward under tectonic pressure, creating geological traps for natural gas and forming deep underwater caverns. Number 5. The floating peat mats of the Merbleu Bog near Ottawa, Ontario. Covering over 3,500 hectares, this ancient peatland features a carpet of sphagnum moss that has accumulated over 8,000 years. Walking near the edge of the bog causes the surface mat to tremble, as meters of saturated organic material float directly over trapped meltwater ponds left by the Champlain Sea. Number 4. The buried river valleys of southern Saskatchewan, carved by catastrophic glacial outburst floods. Beneath hundreds of meters of prairie soil lie deep, gravel-filled channels that once carried massive volumes of meltwater from draining glacial lakes. Today, these invisible paleochannels form crucial underground aquifers that supply groundwater to rural agricultural communities across the dry prairie interior. Number 3. The Manicouagan Reservoir in central Quebec, an impact crater so large it created an annular moat visible from orbit. The central island, René-Levasseur, was elevated during the impact event 214 million years ago, creating a hydrographic ring that holds billions of cubic meters of water behind the Daniel Johnson Dam. Number 2. The ice patch archaeological sites in the Ogilvie Mountains of the Yukon, where melting icefield edges continue to expose ancient hunting shafts, dart throwers, and biological specimens preserved in sub-zero conditions for thousands of years. Number 1. The Hudson Bay gravity low, where the Earth's mantle is still creeping back into place after being crushed beneath 3 kilometers of glacial ice. The missing mass beneath the bay creates a measurable dip in the Earth's gravitational field, proving that the planet beneath our feet is far more fluid and dynamic than human maps ever suggest. What kept these 43 anomalies invisible for so long was not a lack of interest, but the limits of early survey methods that relied entirely on what could be seen from ground level or drawn within the borders of a single map sheet. Today, satellite geodesy, airborne LiDAR, and ice-penetrating radar continue to reveal underlying structures across the Canadian Shield, the high Arctic, and prairie basins, even as rapid climate shifts alter coastlines and thaw permafrost faster than field teams can record them. The map printed on paper always looks complete and permanent, but the ground beneath it remains an ongoing geological investigation. Which hidden landmark or geological anomaly in your own province or territory has always struck you as unusual? Tell us in the comments below, and consider subscribing to follow our next investigative tour across the changing landscapes of North America.